right? So guys, I have to do this over again. Okay, rod elements is an truss element, basically rod elements at an angle, and it is tilted by a theta. Okay, what's going on here? We have nodes I and nodes J. Okay, and there's a force exerting on nodes I and node J, and then at an angle. But that angle is along the truss, along the rod element. And as a result of the force, we have two displacements as well. It's UIX and UJX. Nothing fancy, same as what we had before, but everything we added X at the end. Okay, so we rewrite the whole thing into matrix form. Guys, do you have questions? Any questions so far? Okay, good. So because we are moving everything in a 2D world, okay, so we have to introduce Y terms as well. So UI is able to move along X and Y. But in this reference frame, okay, there's no movement along Y. So we put 0 on for all the Y terms. So from here to here, we just add the Y terms, but there's no movement along Y in the tilde reference frame. So we put 0 there. Yeah, if you multiply that, you end up having these equations. Questions? Okay, now let's see the relationship between the reference frame, the regular reference frame, U without the head. Okay, let's do one term. Let's do one term here. Okay, UI X right here is the cosine of theta UIX has two contributions. This portion and the movement. This term is theta, right? Now, what about this side? This is moving to the left, so it's negative UIY sine theta. We move these two terms over there. You get the first equation. Apply the same theory to UIY, UJX, and UJY. You get the next three equations. Any questions so far? Let's see, do I have any online message?
Sir, why do you have two UIYs there in that picture on the left, on the bottom? Or right where you have negative UIY sine theta. Why do you have two UIYs there on the two members on the top? If they're both taken at the same point for UI. Are you just showing the translation from a regular XY to a one with an angle?
Okay, there is two movement here, right? Sorry, I don't get it. What's the question again?
So so where you wrote the where you started to pan out looking for step 1 here, and you have
Okay,
the arrow going, you have UIX cos theta, which is positive because it's going to the right, and then you have negative UIY sine theta because it's going to the left. That's why it's negative. But on the top there, you have two UIYs, and you have one UIY with the hyphen on the top, or whatever you want to call it, the little hat.
with heads, yeah,
Yeah, and is that just showing out the breakout with the angle? Is that what you're showing?
correct, yeah. So
Oh, okay.
anything with the head is at an angle,
Okay.
and
Okay.
anything without a head is now regular reference frame.
Oh, okay.
And
Okay.
I my intention is convert everything with a head in terms of our regular reference frame without an angle. Let's do one more, okay? I want to find out what's going on with UIY. So UIY right here. Oh, you know what? It's too busy here. Let's do UJY. UJY. UJY is contributed by two portions of it. That portion and okay. So this side is UJY cosine theta. And it's going upward. So it's a plus. This side is UJX hat sine theta. Oh. And also it's a plus, it's going up. So you put this term to here. You get this. Questions? Okay, the force direction, the movement of the note is very important. Anything along Y going up is positive. Anything along the Y-axis going down is negative. For X, anything go to the right is positive. Anything to the left is negative. Okay, we set up 4 equations. We factor out anything with the head. You got a funny looking trigonometry matrix. It's called a transformation matrix. Okay. In this note, I explained to you how to develop the transformation matrix. But in the test or midterm test, do not develop this for me. This is just a development, okay? Don't write this on exam because in a test or exam, you must know how to use the T matrix. Okay, right here, we turn everything with a hat to without a hat by a transformation matrix on a displacement. So same thing. We can apply the transformation matrix on the force as well. Because look, guys, so far, everything I show you is the U, it's the displacement only, right? So what I'm telling you here, what I'm showing you here is the transformation matrix. The transformation matrix can turn the displacement, anything with a head, to without a head. So this transformation matrix is so powerful. It can convert the force matrix, the force vector into the different reference frame as well. So if I invert that, then I can transfer everything with the head to, so anything without a head to with a head with an inverse matrix, right? Let's do some matrix multiplication. Okay. What we learned long time ago. Well, actually not too long ago. Yeah, just 1 hour ago. Yeah, today's the first class. Right? You just put that term. Sorry. That's right. Put this term. Now we have everything in our regular reference frame. I want to calculate everything in a regular reference frame. The question given, the question is given in anything with a head reference frame. Okay, I don't want that. I want to transfer everything into something workable. So I use the transformation matrix 2 times to get rid of all the heads. No more everything is represented in a regular reference frame now. Sorry guys, class not over yet. Can you hear me?
Yes, sir.
Yeah, I hate it. It's just internet glitch. So, yeah, we talk about Matrix too often, eh? It's like the movies, Matrix. So it's a glitch. Okay, let's move on. Almost there, guys. Almost there. What I was saying is, I do not want anything with the head.
Professor, your screen isn't sharing.
That's right.
Thanks
I'm
for the
not sure if you're
reminder.
recording. I think you have to start recording again.
Yes, it is recording.
Yes,
I have to share screen.
Yeah, recording is fine. Just the screen we can't see.
Okay.
No, it is.
Now it is, yeah.
By the way, I split that into 2 recordings. I couldn't find my first one. You know, I have to look around in my computer. You know, that COVID thing is really driving us crazy, huh? Okay, sorry, where was I?
You're showing the F, K, and the U.
Okay, what I'm saying is that I don't want anything with a head. I want to transform everything with from the head reference frame to the regular reference frame. So with the help of 3 matrix, T, K, and T negative 1, T inverse, I have a new stiffness matrix. Okay, and that stiffness matrix will turn everything with the head into something without a head. Question so far?
For these matrices, for the T, K, and the inverse T negative 1, the C negative S, is that just grabbing the cosine and the negative sign and
Correct.
breaking it down?
Yes. Any C is a cosine. Any S is a sine. Okay, I don't write the whole thing because I just want to save time.
Yeah.
And again, during the test or midterm, whatever, don't show me the development of this, but you must know how to use it. How do I use it? Yeah, the example is coming up. Okay, there's a truss. It contains 2 elements. Element 1 is linking nodes 1 and nodes 2. The second element is linking nodes 1 and nodes 3. Okay. The 2 elements have the same properties. Okay, the elastic modulus is 250 gigapascal. The cross-section area is 5 centimeters squared. Okay, and there's an angle on element 1, and there's a force acting on node 1, and at the same time there's a displacement. Wow, on node 1 as well, 5 centimeters down. Okay, the question is find the nodal displacement of all nodes. Well, obviously nodes 2 and 3, they're not moving, so we know already nodes 2, nodes 3, 0. The nodal force of all of them, nodes 1, 2, 3, axial force and stress. Okay, the first step, let's turn everything into something workable. Okay, it is Pascal, so everything's in Newton per meter square, right? So we transfer everything into meter square. Area, and this is Pascal, so Newton per meter square. Okay, so in this case, we know K1 is what? EA over L. Okay, now will be A times E divided by L. Okay, element 1 is 5 because this is 3, 4. So this element will be 5 meters. So you get this. And at the same time, elements 2, we have a K value as well. Okay, let's move on. Hey, look at that. Basically, when you see a truss example, here are the steps. First step number 1, change all the units into something workable. Number 2, name the elements. Elements 1, 2, and also, I forgot this, name the nodes as well. Now, step 3, let's set up an information table for the elements. Okay, the table has what? It must tell you the elements, number, the nodes, the angle, K, and the cosine, sine, and cosine square on these things. Okay, let's try it on the first element. First element is linking from node 1 to 2. What angle is it? We do not know. However, do we need an angle in this case? No, because all we care about, we want to set up a transformation matrix, right? So all we need is the cosine and sine of nodes 1, sorry, of elements 1. So elements 1 linking from node 1 to 2. So from, we have the K. We have the K from previous section. And the cosine of node 1 to 2. Now, this is very important. We're not, depends how you define it. Right here, I am using nodes 1 to 2. Nodes 1 to 2. So I'm moving from 1 to 2. The cosine of that will be -4 over 5. And the sine for nodes 1 to 2 will be +3 over 5. Guys, do you have questions so far? This is very important though. Any message from the chat?
So sine is only dictated by x and y, not with the h, right?
Well, sine is the opposite side over the slope, right?
No, the
How about-
negative sign.
Okay, the cosine. I
Yeah,
am.
cosine is negative because the x direction is going in negative.
That's right. That's right. -4.
We don't consider the direction of the 5, the line that is 5 meter long.
5 meter long is constant. It's not changing anything. Okay. What about, what if I have node 2 to 1? Then what is my cosine?
The cosine will be
It'd be +3 over 5.
The for 2 over 2 to 1. For 2 to 1, the sine will be -3 over 5 because it's going downward. 2 to 1 is going down. Okay, so will be -3 over 5, and the cosine will be +4 over 5. Okay, let's do work on the next elements. Next element is linking from node 1 to 3. So from 1 to 3, it is 180 degrees. Okay, and the cosine for that will be -1 over 1, and sine will be 0. So it's all good.
Can you repeat that again?
From node 1 to node 3, I want to have a sign which is the opposite side of the angle over the length of the hypotenuse. Okay. From node 1 going to node 3 will be -4/4. Cool. So I have that cosine is -1, and yes, what is
The
it?
hypotenuse was 5.
The hypotenuse is 5 if I'm jumping from node 1 to 2. But now I'm jumping from node 1 to 3. Get it?
Yeah.
Okay. We have two trigonometry equations here, right? Two trigonometry problems. Okay. So we have cosine and sine, then obviously we have cosine square, CS, and S squared. The next step, we have to assemble the K matrix, just transformation matrix. How do we do that? The reason is we set up the table is nice and clear. We want to know the C square, CS, C square, S square, all these things. Now we have a good table. We plug in all the numbers. We have K1 and K2. Now, next step is very important. How do we use that? How do we link? How do we link two matrices together? Okay, first of all, let me explain that. This is the element looks after node 1 and node 2. Node 1 and node 2. These 4 entries look after the node 1, and then these 4 entries looks after the node 2 only. Okay, and this one looks after the relationship between the nodes 1 and 2. Similarly, this 4x4 matrix looks after nodes 1, 3, and 1, 3. Clear so far? Okay.
What about the bottom left quadrant where you have your like -16, 12, 12, and -9, the one that you didn't square? Is that also the relationship between the two nodes?
2 nodes, that's right.
Okay.
So we have 2 4x4 matrix. Okay, what it does is transform the relationship or the displacement in the hat reference frame to a regular reference frame. And the construction of this table of the matrix is prepared by this information table. I want to see that in all your assignment or quizzes, tests, exam. The next step, we put both things together. Okay, it is a 2 by we have 2 4x4 matrix. However, we share 3 nodes only, right? So each node moves X and Y. So that's why the vector has 6 entries. So displacement has 6 entries, because nodes 1 can move x and y directions. Nodes 2 also move x and y, and nodes 3 same thing. Same as a force factor, okay? As a nodes 1, 2, and 3. Now we put it, we put both matrix and combine them together. Many entries are just strict copies, you know. Like for example, this one, we move everything into here. The only difference is I'm adding this section to this section and create a new entry right here. 16 plus 31.25. We got 47.25. That is the global matrix. Okay. Now the next step, we have to apply the boundary conditions. That is my favorite part. We know nodes 2 and nodes 3, they're not moving at all, right? So they're all 0. I love 0. Guess what? Because anything multiplied by 0, it turns to nothing. I can reduce a big matrix into a small one right away, okay? U1y is moving down by 5 centimeters, right? So this is negative 0.05. U1x is something that we don't know. We have to solve for it. Now let's look at the force vector. We only know node 1 is being pressed on the x direction by 1,000 kilonewtons. So it is -1 times 10 to the 6. But what about other forces? Can I assume that in a 0? No, because F1y, F2x, F2y, F3x, all these 5 terms is holding everything together. There's one little trick, okay? If you have a known values on the right side, 0, everything is known value. You very often you have unknown values on the left side. If you have a known value on the left side, you have something you don't know. It's an unknown on the right. So this is a 6 by 6 matrix. It generates 6 equations, and we have what? 6 unknown in total. Clear? The rest of it is very boring. We just multiply everything together. Anything touched by 0 is gone. Okay, and we're down to 2 equations only. Let's work on the first one. The first one is we rewrite this here. We multiply the scale factor. Oh, by the way, one thing I forgot. If you add 2 matrices together, make sure they have a common scale factor. Matrix is like a bracket. If you don't have a common scale factor, it won't work. You cannot add 2 things together without a common factor. Okay, and negative 0.05 times 12, you get this, and you have the 1 equations, 1 unknown. You get U1x is 0.03386. Now you have U1x. You put everything back to the equations, and you solve for all forces. And finally, you rewrite everything. This is a total force factor, and that's the total displacement factor. Okay, one final step. You have all the forces, right? You write that into a free body diagram. Okay. And then with this, you can find out the stress on each element here, because we have all kind of forces right here, right? The rod is being pulled or being pressed. Okay, first step, you draw something and you write the force on each node. And then we break it down. We use the equation, okay? Now, this is right here, or the force right here is the one with the head. I'm sorry, that's the one without the head. Because that is without head. This is with the head. I want the stress along the elements. So I have all the information without a head, and we use the T-1 matrix, sorry, T inverse matrix. And we multiply that, we have F1x, because guys, check this out. When I times everything by T inverse, all the Y values is gone, because, my goodness, I'm so sorry. That's the right angle. Yeah, when I transform everything, there's no more Y values because it's not moving in the Y direction at all. It's only X. So we find out the actual force acting on the rod, along the rod, is 72.72 kilonewtons. And we divide by the area, we get a stress. We repeat the same thing to elements number 2. And then this one is a lot easier. We don't have to do any transformation at all because there's only one force on it. And that's the compression load on it. So guys, that's all the lecture for today. Any questions so far before I do the recap?
Can you go back to the last note for truss element theory?
Tell me when to stop.
Keep going.
The note, not example. It's right here.
Yeah, you're coming up on it. Keep going. Keep going up a bit. So when you make this matrix right here with, when you just put in your angles, like your cos theta, your sine theta, what would you like call the columns in the top? Like the first two is obviously for like the first node, the first 2 columns on the left, and then the second 2 columns would be for like the second node, right? Like how would you kind of title those columns if you wanted to kind of explain it more in depth?
Why do you want to name it though?
I'm not sure, just kind of, yes, like, yeah, how would you like title each column sort of going across, right? Like
I would
Obviously,
say
it's the top left quadrant there is with respect to UI, and then just the UI X and UI Y. Like, how would you explain those?
I X,
Okay,
I Y.
okay, and then the next
but
one would be
J.
X and JY.
Yeah, J X and J Y. But you know what? I see that confusing though. Usually I just name this term, the whole thing, the whole mess looks after the I node. You know what? Let's
Yeah,
go
I
back to
can
the
see why
example.
it's with respect to I, but I just kind of wanted to
Yeah,
kind of see through the whole way, kind of.
I prefer we name it like we did in our example. So if node R, node 1, node 2, and node 3. Okay. I will show you another Truss example next week. We are kind of ahead of schedule. Okay. My intent for today is just show you raw elements. So now we have a brief introduction on Truss elements. And it's not over yet. Next week, I will show you more examples on Truss element. Okay, so for today, what have we learned? We have learned the simplest element, the spring element. Okay, why we learn FEA. So the homework for you guys, number one, review the note in week 0. Okay, how we multiply matrix together, you know. And then second work task for you is review the notes on raw element and finish the assignment. And upload into Avenue to Learn. Okay.
And where did you say the assignment was again? In the email?
The assignment is not in the email. It should be in your assignment section.
Yeah, posted in assignments.
Yeah,
it's
post
at the
in the
bottom.
assignments.
Sir, I had a question on those notes, the trust notes. You kind of put the, if you go back to your slide, I think it's number, page 2 of 5. You know, when you explain moving from the global and the local to the F, yeah, you see how you have the F hat equals K and the U. If you go up on your previous page, you put U hat equals T inverse U, and then the F hat is T, the inverse times the F. And then you're going down further into the next page when you're showing the T inverse F. Where are you getting the single T from? I'm not understanding the translation. Is there a mistake on one of the T inverses there? See here how it says T inverse -1 is the F equals K times T inverse U. And then you have a single T. Where's that single T coming from? The math is not working out for me. Yeah, that's an inverse. Oh, okay. All right, okay.
What I did is just I timed the whole thing with T.
Yeah, I understand now. Okay. That makes sense. A little
Okay.
rusty on matrices here.
So you sleep better tonight? Yeah. Okay. Assignment. Okay. Number 1, review notes on week 0. Number 2, okay, in each note, I ask you to review some notes in the textbook. It's optional. You don't really have to. You know, my note or the examples we go through in class is good enough. The textbook is, if you really want it, you can buy it, but not. It's way too complicated, way too much work on it. When I read the textbook, I have difficulty understanding, but because those guys are so smart, you know. I try to translate everything into something simpler, you know. Anyways, week 1, note, homework number 1, review week 0 notes, and and then review the notes for rod elements as well. And then review the notes on the truss elements that I give you so far. Okay, you know what, the best things to work on it is just repeat my examples, you know, hide the answer that I provided, you know, examples, and work on it on your own. And why did I jump from this step to next step? And how do I go from step 2 to step 3? Okay, so review notes on a week 0, rod element and truss element, and finish off one homework in the assignment section. Okay, try it out. I hope you like FEA. If you have questions, send me an email. I'll try to reply it ASAP. And for my homework, it's a challenging one. Hopefully, I can find all the recordings and upload in YouTube. Okay. Anything else before we hang up? Hearing none, that's it for me. Thank you for attending my class and wish you have a good weekend. Okay. Goodbye, my friends.
Thanks. See you next week.
Thank you.
See you. See you.